lives are in danger. What I'm going to be doing is talking about making some urine and trying to make up the class that we're missing today. So starting at the bottom of page 56, this is where we left off last time, and we talked about the renal corpuscle. So the picture you're going to be looking at when you're looking at the renal corpuscle is this one right here. So the renal corpuscle is made up of the glomerulus, and the glomerulus are these capillaries right here that you can see in red, plus Bowman's capsule. And Bowman's capsule is what surrounds the capillaries. And Bowman's capsule is the first part of the renal tubule. So we're going to be looking a lot at this picture today. The other thing that I showed you on Friday was kind of my own homemade renal corpuscle. So I showed you here, this was supposed to represent the glomerulus, so just a whole bunch of 20 to 40 capillaries. And then here, the cups here, were supposed to represent Bowman's capsule. So the renal corpuscle was glomerulus inside Bowman's capsule. Okay, so we're going to go back to glomerular filtration. And glomerular filtration is the process then that occurs in the corpuscle, so that specific part of the whole nephron. And it's important in urine production. And basically what you have is some of the blood plasma, so almost all of the blood plasma. And if you remember blood is separated into plasma and the formed elements. So the plasma was made up of mainly of water and some electrolytes. And so you have most of the plasma leaving the blood in the glomerulus and entering into the space here of Bowman's capsule. And that space we'll talk about in a second is between the inner layer of Bowman's capsule and the outer layer of Bowman's capsule. And what you now formed, the fluid that you formed that's now entered into this space right here, is the filtrate. And so this is basically all of plasma except for proteins. So you really should never have any proteins coming into the filtrate. So that was the bottom of page 56. So now if we go on to page 57, so we're looking here, we're moving on to page 57, we're going to look into more detail of what makes up Bowman's capsule, or the glomerular capsule. So this is figure 26.8 in your book. So the glomerular capsule, again we're going back to this picture right here. Glomerular capsule is made up of an outer layer and an inner layer. The outer layer, these terms, familiar terms, outer layer is the parietal layer of the capsule. So that's what you're looking at right here. And if you look at the epithelium that makes up this parietal layer, you can see that each of the little cells are really flattened or squashed. And so these are the parietal layer is made up of squamous epithelial cells. And then you have the visceral layer. And the visceral layer, they've removed most of it in this picture so that you can actually see the capillaries. But the visceral layer is going to be right here on top of the capillaries themselves. So that's the visceral layer of Bowman's capsule. And the visceral layer of Bowman's capsule is made up of specialized cells, and these specialized cells are called podocytes. So we're going to look at that in more detail. So, and then between the visceral layer and the parietal layer, you have the space, the capsular space, and that's where I just talked about where the filtrate gets emptied into. So if we look at this again, we have here the glomerulus. Then in direct contact with the glomerulus, you would have the visceral layer of Bowman's capsule, and this layer would be made up of those cells called the podocytes. And then the red cup here is supposed to represent the parietal layer. and then in between you'd have the space. So what we're going to do is we're going to, back to this picture here, we're going to look at these podocytes here that are making up the visceral layer of Bowman's capsule. So we have another figure that shows that. Okay, so here we're looking at another figure. So they're just showing you right here is the picture that we looked at before. And then we're looking now at one of these podocytes right here. So that's what we're looking at right here is a podocyte. So what do you need to know about these podocytes? Well, these podocytes, they actually form little tertiary processes. So if you look here, these little processes right here, and those little processes are called the pedicels. So you've got the podocytes. Pod means like foot. So like a podiatrist is a foot doctor. Yeah. And then you've got the pedicels, which are just these little processes coming off the podocyte. And a pedicel is like a little foot. Like if you get a pedicure, you know how you're getting that. So,
that's cute.
Yeah. So what do these pedicels do? Well, the pedicels are actually sticking onto the basement membrane that's covering the capillary's endothelium.
That's nice.
So if we back up a little bit. So if you look here, what this is showing you, here's the capillary. So you'd have the blood running through the capillary. Here is the endothelium of the capillary in yellow. Here's the basement membrane of the capillary. And then on top of that, you have the little pedicels of the podocytes. So what these little pedicels or little foot processes are doing is they're actually, what they say, interdigitating with each other. So they're playing footsie with each other, kind of. So, and what they do when they do that is they're actually making a little network of clefts here. So if you look, you have these little clefts. And those are called the filtration slits or the slit pores. And then you have a slit membrane covering those slit pores. So basically then, if we're going to look at what all of this picture is showing you, you have the glomerular capillaries, and here is supposed to be the endothelium of the glomerular capillaries formed by a single layer of squamous cells. But the endothelial cells have small pores. So this is a fenestrated endothelium. So in order for anything to move from the blood within the capillaries out into the space here, so for filtrate to actually get filtrate, you have to go through what's called a filtration barrier or a filtration membrane. And that's what's being shown here by these arrows right here. So you have 3 layers of this filtration barrier or this filtration membrane between the blood in the glomerular capillaries and the capsular space. And it's made up of, again, the fenestrated endothelium of the capillaries, the basal lamina or the basement membrane, and finally the slit membrane that's covering the filtration slits between those pedicels. So any substance that wants to get from the blood into the Bowman's capsule space and kind of make it into the urine, this is the one way, or into the filtrate, which ultimately can become urine, that they'd have to pass through this filtration barrier. And in order to pass through this filtration barrier, you don't have to really be special. So, Elise, can you keep it?
Yeah.
You don't really have to be special. So, all you have to be is less than 3 nanometers in diameter, and that will let you get through. So you have to be small, but you don't have to be really special. So the glomerular filtrate are most substances in the plasma except for plasma proteins. So you really shouldn't ever, like I mentioned, ever see plasma proteins in the filtrate, and you shouldn't see plasma proteins in the urine. So the other thing, kind of just information of interest is that negatively charged glycoproteins are associated with the filtration barrier, and they influence the movement of molecules across that barrier. So when molecules are moving from the blood into the capsular space, how fast they move depends on their size and their charge. So the smaller you are, the faster you are. But if you have a bunch of molecules that are the same size, the positively charged molecules are going to be faster than the neutral molecules, and the neutral molecules are going to be faster than the negatively charged molecules, because that negative charge associated with the membrane will kind of repel the negatively charged molecules and attract the positively ones. Now, when do you have problems? Always careful. When do you have problems is when you have damage to the filtration membrane. So like if your kidneys are inflamed or you've had trauma to the kidneys, you can damage this whole barrier here. So any of these layers, if they're damaged, and what can happen then is that you can end up with protein ending up in the urine, and that's called proteinuria. The main protein is albumin, so albuminuria is kind of the same thing. Or you could end up even with blood in the urine, and that's referred to as hematuria. So if the doctor finds protein or blood in the urine, it could be an indication that there's been damage to this membrane, and there's something wrong with the kidneys, since the nephrons are basically what are making up the kidneys. Okay, so that's page 57. Okay, so the rest of the notes that we're going to be looking at starting on page 58 is we're going to be looking at the rest of the renal tubule. So we looked at these two pictures last time. And remember, the nephron is the functional unit of the kidney. So we had two pictures of the nephron. We were looking at juxtamedullary nephrons, and we were looking at cortical nephrons. So here's the cortical one, which is the shorter one. And what we're talking about and what we've been talking about today is going to happen in both these nephron types. So really there's not much difference in terms of the different parts of the nephron and what's happening within the nephrons based on what we're talking about today. So again, a nephron is made up of the glomerulus, which are the capillaries, and then you've got the renal tubule. And the first part of the renal tubule we already talked about, that's Bowman's capsule. And now we're going to look at the rest of the renal tubule and the different parts that make it up. So we're going to start with the first part, which is the proximal convoluted tubule. So